Professor Belfrost's science class is back.
Hi, welcome back to this channel. And today we'll again discuss another concepts related to science. So here's the science tutorial for you today. Are you ready? Let's continue playing this video. Okay, so welcome back. And this is the sixth video on exam problem discussion. I mean the new one, new episode. Okay, so yeah, let's see. Let's move from yeah. This is the first one for today. So please affiliate the yeah. So integral of uh, 1 plus square of 3 over x plus 1 square 1 minus x is the power of 6 and together they are the power of quarter. Mm, so say that the result is I for this integration. Actually it's missing something. Oh, this one. Okay, so you need to change the form first to solve this one. Okay, maybe you want to take this out, okay, like this, and then you create the neutralizer in this form, okay, in a ratio form. And if you find out that actually 1 plus x raised to the power of minus 6, okay, when we raise to the power of 1 quarter, a quarter, I mean, it makes it minus 3 halves, okay, and when we subtract it, 2 minus 3 halves, it is a quarter. Not one, it is half, right? So it's the same of 2 raised to the power of, okay, is the same as 1 plus x raised to the power of 2 times 1 quarter, a quarter. So it's the same meaning. And now we can try to solve this part, okay, because this is a constant, we actually don't really need to pay attention to this one. So say that 1 minus x plus 1 by 1 plus x, it is t. Then if we take a derivation on both sides, okay, it means it become dt. And because actually it has similar form, actually this is just yes, because this is actually you put it up, okay. So this becomes square, and the minus stay minus here, and this 2 here, okay. So minus 2 dx by 1 plus x squared equals dt. And now you substitute this into the form. Okay, so you change the dx into 1 plus x squared by minus 2 dt. Okay, and also this form, you change it to, yes, here's the power of 1 squared. Also this one, 1 plus x squared, also you change it into respective form, which is minus 2 dx by dt to get this form. And then you just need to extract the constant to the left side, and you just need to operate this one first by solving to the boundary. Okay, oh, one again, that now you are operating on dt, not dx, so the boundary value will be different. Okay, it will be different. It's from half 0 to half to 1 to 1/3. Okay, you need to find it first before it's not shown here, but you need to find out the new boundary. So the result is 2 after you do the operation. Second question on physics. 1 mole of a monoatomic ideal gas undergoes an adiabatic expansion in which its volume becomes 8 times its initial value if the initial temperature of the gas is 100 Kelvin and the universal gas constant R is 8 joule. 8 joule per mole per Kelvin, then the decrease in its internal energy in joule is, this is also simple. First you need to memorize, yeah, it is, yeah, a must. I'm sorry, you cannot do this, so you cannot solve this problem if you don't memorize the formula of an adiabatic process. So this is a formula. So actually this is T1 V1 gamma minus 1 equals T2 V2 gamma raised to the power of gamma minus 1. Yeah. So the T is T, V is V, the T2 is the one that you don't know, and the last V is, okay, I mean the final volume is 8 times its initial value. It means that 8V is the thing like that. Okay. And what about gamma? For monoatomic ideal gas, it is a factor. Okay. So by substituting this all into the previous equation, we get that the final temperature is just a quarter from the initial temperature, and further that the change in the internal energy is described as ncv delta t, where cv here is f, okay, by 2r. Okay, so what is the f here? Yeah, nfr by 2. Delta t is, okay, t quarter of t minus t is minus 3 quarter t, right? So F is 3 here, okay, for monoatomic. Okay, so minus 1, the 1 mole times 3 times R 8 by 2 times 3 quarter times the T. The initial temperature is 100, so it is minus 900 joules. The third problem related to chemistry. The order of the oxidation state of the phosphorus atom in, yeah, we have some of this, okay, is, yeah, actually this is very easy. First you need to know that for this kind of thing, hydrogen is plus 1 and oxygen is minus 2. Actually you don't need to be very difficult. This is PO4 with minus 3 charge, so it means that minus 3 plus 4 times 2, it is plus 5. For this it means that it has minus 4 charge. It means that minus 4 plus 6 times 2, it is 8 by 4. I'm sorry, 6. 6, 2, 12. Yeah, 12. So 8. 8. Yeah, 8 by 2. Okay, this is plus 4. Okay. And this is PO3, 3 minus. Okay, minus 3 plus 3 times 2, it means 3. Okay. And PO2, 3 minus, the last specimen. So minus 3 plus 2 to 4, yeah, 1. Okay, 4 minus 3, 1. Okay, so the correct order is this, which is C. Yeah, before I end the video, I want to share a quote for you today. So, happy people plan actions, they don't plan the result. I mean, they enjoy the process. Okay, this is from Dennis Waitley. That's the end of the video for today. Thanks for watching, thanks for following so far, and here's what you need to do. Please subscribe, give a thumbs up, comment, and share this video to your friend. And also, don't forget to check our website at https://science-expo.uanaux.com, and I'll be back on every Tuesday, so keep watching and be thoughtful. Goodbye, see you on the next episode.